Dear student, Assalamu alaikum. I hope you are doing well. So this is Kazi Kamrul presenting new class regarding indices, which is very important for IGCSE O level as well as for SSC also, and very essential part for learning and preparing for those examination. And index is actually the plural form of index. So যেটা আমরা বাংলায় সূচক বলি, index actually, if I write, for example, write 10 to the power 3, here 10 is called base and 3 power, or simply it is called index. So 10 to the power 3 means multiply 10 thrice itself, so 10 again 10, so that's why write 10 to the power 3. So if I write a to the power 3, that's mean a times a. So we will learn some set of rules regarding these indices. Okay, let's start. Rule number 1. Rule on for a to the power n. If a to the power n, a to the power n. So we have common base here. So that's why we can write a to the power m plus n. So for example, if I write 2 to the power 3, then 2 to the power 4. Basically, it will be 2 to the power 3 plus 4. Okay, 2 to the power 7. Then rule number 2. Rule 2 says a to the power n divided by, or if I write divided by a to the power n. So we have common base here, different power m and n. So basically we can write a to the power m minus n. Or if you write a to the power m divided by a to the power n means a to the power m divided by a to the power n equals to a to the power m minus n, when a m greater than n, or another format a to the power 1 by n minus m by m less than n. But ignore this for simplicity. You can ignore this formula for now, because another rules for understand this part, which is known as the negative indices. So basically these are the formula. Rule number 2, a to the power m minus n. For example, if we take an example, 5 to the power 4 divided by 5 to the power 2, then we can write 5 to the power 4 minus 2 equals to 5. 4 minus 2, 2, so 5 square, 5 square means 5 times 5, that's why 25 is the correct answer. Rule number 3, a to the power m, again in power. So power and power always will be multiplied themselves. So that's the a to the power n. So it actually power এর উপর আবার power. So power always multiplication, or এটা power গুণ হয় যেটাকে বলা হয় a to the power n. Or if we write a to the power n, we can go back a to the power n, then again n. So for example, if I write 4 square again 3. Then it will be 4, 2 and 3 multiply 2 and 3. So 6, 4 to the power 6. Then rule number 3, rule number 4. 4. So if I write 4. So if we write a to the power n and b to the power n. So now common power. So for the common power we can write a times b then to the power n. So when we get common power here, common index, that's why you can write a to the power n. So for example, suppose 5 to the power 2, also 3 to the power 2. So then we can write 5 times 3, then to the power 2. So rule number 5 also similar. Rule 5. Rule 5. Common base a to the power n b to the power n, b to the power also m. Then we can write a by b to the power n. For example, so if we write 7 to the power 2, also 5 to the power 2, then we can write 7 by 5 to the power 2. So common power here, if it is in division phase, then we can write like this. Then okay, I have to erase this part. Rule 6. Rule 6. Okay. Zero indices. For example, anything, if it got power 0, then we can write 1. Suppose a to the power 4, if it is divided by a to the power again. So for following rule number 2, it was a to the power m by a to the power n. Then we can write a to the power m minus n when a not equals to 0. So then if we apply this, it will be a to the power 4 minus 4 to the power 4 minus 4. So simply a to the power 0. But so if we did like this, a to the power 4, a to the power 4, common factor here, they are in division, that's why you can cut them or simplify them. So it was as a result 1. So that's why a to the power 0 equals to 1. So these are the proof, simple. Again another example. So I can recall this when n less than n greater than m, then it will be like this, 1 by a to the power n minus n. But this is a little bit difficult, that's why we can ignore this. But we know another format, another rule, rule 7. So a to the power negative n. So for this negative we can write its reciprocal. For this negative, only reciprocal responsible for this negative sign. So 1 by a to the power n. So this 1 by is reciprocal of this a to the power n. So anything, if it has any negative power, then we can write 1 by a to the power n. For example, if I write 5 to the power minus 2, then we must write 5 to the power 2. So 1 by 5 square. So these are the rule. Some radical function like this. So if I write a square of anything, for square of 9, so actually this is a square root. A square root here 2, not written here, but this is called a square root. So anything n root a equals to a to the power 1 by n. So root 9 equals to, you can write 9 to the power 1 by 2. But here anything, another rule number 8, another rule number 8, rule 8, n root over a to the power n. That's why it will be a. Rule for rational indices. Rational indices. Rational indices for n positive roots and positive roots. Roots, actually if we write root 9, it means 3 times 9 equals 3 times 3. That means 9 is a perfect square number, so we can write 3 square. So root 9 actually root over 3 square. So this is a square root. Here 2 is not written here, but square root. But cubic root written like this, cubic root. Okay, I'm coming here, but this gonna be root over 3 square. That's why its answer is 3, right? n root over a means a to the power 1 by n. So this is another rule. N positive roots root over a to the power 1 by n. While a must be greater than 0. That means a must be positive number. So if we apply this formula here, so a square root inside 3 square. So 3 square to the power, so as because this is 2, 1 by 2. If we apply this formula here, so 3, so again you know another formula, a to the power m to the power n equals to a to the power n. That's means power into power. So here 2 into 1 by 2. So this 2 is in middle position, this 2 in down part. That's why we can simplify them. So 3 to the power 1. 3 to the power means 3. So as an answer 3. So if we do this like cubic 27. So 27 equals to 3, 3 and 3. So why do we do that? 27 actually divisible by 3. First it is a odd number. So 3, 9, again 3, again 3, 1. So we had factors, prime factors like this. 3, 3, 3 thrice time, 3, 3, 3, that's why 3 to the power 3. So here 3 to the power 3 cube. So 3 to the power 3, and second, as because this is cubic root, 3, so it will be on by 3. So 3 and 3 cut themselves, then 3 to the power 1, 3. These are the basic thing inside story of rational indices. Basic